Jens will give you an all clear. And try to stay in the view field of the camera.
Between, yeah.
Like here? Okay. So I'm going to go over a little bit about my background, why I'm interested in the stuff I am, how I got into this kind of stuff. So this is just thank you. This is a photo of a research expedition I was on an undergrad. That is me right there. We were going out, skiing out to collect a snow pit to study climate change in Southeast Alaska. So how I got interested in this stuff in general is, as I was growing up, I spent a lot of time in the mountains. I'm from the Pacific Northwest of the US, and I had a lot of opportunities to spend time outside. And because of this, because of being a really young age, being in the mountains a lot, I really got interested in them, and I wanted to learn more and more about the mountains that I was spending so much time in. And so as an undergrad, I got a geology degree, which was super awesome. I really enjoyed it. But I always wanted to study some ice stuff, and that wasn't really an option where I went to undergrad, and it was something I was always really interested in. So then I got the opportunity as an undergrad to be part of the Juneau Icefield Research Program, or JERP. It's this research expedition that happens every year in Southeast Alaska, where we spend 6 weeks skiing across the Juneau Icefield from Juneau, Alaska to Atlin, BC, doing glacier science and climate science along the whole way. So what I was doing in there was I was studying the snow chemistry of the Juneau Icefield and seeing what we could learn about past climate by looking at the chemistry of the snow. But while we were up there, I was really struck by a question of, so we're studying the chemistry in the snow, hoping that'll tell us about what the weather was like in the winter, but the Juneau Icefield, in the summertime when we're there, it's actually quite warm. It's above freezing and it rains all the time. So I was confused as to why we were looking at the chemistry of the snow and assuming that the chemistry that was there was a signal from the snow instead of being like washed out and affected by all that rain that was hitting it all the time. So that's what ended up bringing me to Ohio State, because they have a really good ice core research program here. And what I was really interested in was looking at how the snow that falls, how the chemistry in of that snow grain changes after it falls, due to interactions with the air and other things as it gets like buried more and more and more. But because this is really important, because we use ice cores, by looking at the chemistry within those ice cores, we try to decode what past climates were like. And so if that chemical signal that we're looking at isn't actually, a preservation of the snow when it originally fell, then there's a lot of stuff that we have to re-examine about how we use ice cores to decode past climates. So the case study that I'm looking into is an ice core from Mount Ortles in Italy. We are looking at the snow chemistry there because there are a couple of places in that ice core record where the chemical signal does the exact opposite of what we expect it to do, given the weather data we have. So we're trying to figure out, why is that happening? And if we can actually figure out why that's there and how that works, it'll help us better understand what ice cores are actually telling us when we're looking at their chemistry. Oh, wrong button. Okay. Are there any questions? Sweet.
Yay!
Thanks.
Great. So that was 4 minutes.